Hello everybody and welcome to the Creatrix YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we will support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable ECE student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code Ankit ESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code Ankit ESE. Now, my dear friend, if you like the content that I deliver, you can watch more of my free videos on this URL, tinyurl.com/AnkitESE. Here you will find all my videos arranged subject-wise, chapter-wise, and you will find great content for free. And you are definitely going to love it. You are definitely going to enjoy. It not only includes conceptual videos, but it also includes problem-solving sessions. So just visit this once and you will fall in love with this URL. Don't forget it. It is a lifeline for you. And if you love the content that we are delivering on YouTube, we have created the first ever video book for you guys, where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends, that is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link, so write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of, and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that a Plus subscription gives, along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you, which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code Ankit ESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, in the previous few videos I have told you about the BJT amplifier. We have seen different models of BJT amplifier like Ebers-Moll model, which was non-linear. Then we saw the T model or the RE model, then hybrid model, and then hybrid pi model. But the common thing in all those models was that we were only making use of resistances and the dependent sources. We were never considering any inductance or capacitance inside the BJT. But practically what happens when we talk about electronic circuits, then capacitances play a very important role. Similarly, when we talk about electrical circuit or the high power circuit, their inductances dominate. So you can't ignore these frequency dependent devices such as capacitance and inductance. These are also termed as parasitic, okay, because they are present inside the device, though they may not be desirable. So capacitances are mostly considered in the low power circuits or the electronic circuits, and inductances are always considered in the high power circuit or electrical circuit. So in this video what we'll do is we'll try and understand how does the gain of an amplifier vary when we vary the frequency of input signal. See, up to now what we were deriving is when we were talking about overall voltage gain. When we were talking about overall voltage gain, what we were doing? We were writing AVS is equal to V0 by Vs. It was coming out to be some constant term. But now what I will see is how this gain must be a function of omega, or it must be a function of frequency. So the variation of gain with the frequency of input signal is called as the frequency response. So when we talk about response, there are basically two types of response. One is called as time response. It means variation of output with time. That is, as the time changes, how the output will change. Similarly, when we talk about frequency response, what does it imply? It implies variation of output or gain with frequency of input signal. Okay, as the input signal frequency changes, the variation of gain is called as the frequency response. So as you can see, we have taken the gain in decibel. Now how do we take the gain in decibel? It is nothing but 20 log on the base of 10 mod AV. That is your gain on the scale of decibel. Then frequency is taken on log scale. That means it is not actually frequency, but it is log of frequency. Okay. So now you can see that there are three frequency ranges that we have specified: low frequency, mid frequency, and high frequency. So whatever we have studied so far, there we had seen that the gain was constant. That means we were talking always about the mid frequency range, because in mid frequency range, if you see, the gain is constant. Okay. So someone might ask you in a question, if he wants to make it tougher for you, he might ask you, find the mid frequency gain or mid band gain. This mid frequency can also be called as mid band. Band means the band of frequencies or range of frequencies. So mid band gain does not vary with frequency. Mid band gain is always constant. But as you can see, at high frequency and at low frequency, the gain decreases as compared to mid frequency range. Now when the gain decreases by 3 dB, we call that frequency as the cutoff frequency. So the term cutoff frequency is also referred to as 3 dB frequency. Okay, that is the frequency at which gain at cutoff frequency is equal to gain maximum minus 3 dB. So when the gain reduces by 3 dB, we call that frequency as cutoff frequency. Now how it is defined is, see, suppose the gain becomes maximum gain by root 2, suppose. So 20 log maximum gain minus 20 log root 2. So this will come out to be 20 log maximum gain. 20 log root 2 is 3. That means where the gain becomes maximum by root 2, in dB it reduces by 3 dB. So you can also say if this gain is A, this is A by root 2. Okay. So at 3 dB frequency, the gain becomes 1 by root 2 times the maximum gain. Now why we have taken 1 by root 2 specifically? I told you that in AC, power is proportional to amplitude square. So when amplitude or gain becomes 1 by root 2, then power will become half. Okay. So this is also called as half power frequency. Are you getting my point? So when the gain reduces by a factor of root 2, in dB it is reduced by a factor of 3 dB and the power becomes half. So half power frequency, cutoff frequency, 3 dB frequency all mean the same thing. That is when gain becomes maximum gain by root 2. Now our focus in this section will be to understand what are the factors that are reducing the gain in low frequency and high frequency region, and how can we find out these cutoff frequencies FL and FH. Okay, this we have to understand. So next thing that we are going to study is the capacitances in the BJT amplifier. So I have showed you 3 capacitances, this CC1 and CC2. These are called as coupling capacitors or coupling capacitances. Always remember, these are external capacitances connected outside the BJT. Now what is the purpose of these 2 capacitances? The purpose of these 2 capacitances is to connect the supply to the amplifier and take the output from the amplifier. So these capacitances become short circuited in AC, and that is how the input signal and the output signal get connected to the amplifier. So if you have to define in one line, what you will say? Coupling capacitors connect the source and the load to the BJT amplifier. They are coupling the source and the load to the amplifier, hence they are called as coupling capacitor. Now I have told you about this CE also. I have told you in AC analysis we short circuited this CE. When we short circuited this CE, this resistance became short and gain became high. So this CE is called as ammeter bypass capacitor. Okay, now the purpose of this capacitor is to bypass Re so that gain does not reduce. Otherwise, Re acts as negative feedback which reduces the gain of the amplifier. Then the other two capacitances CD and CT. What we know is suppose we are talking about common emitter amplifier. This actually is common emitter amplifier because see, this is emitter terminal which is grounded. Input will be at base and output will be at collector. So in common emitter amplifier, the base emitter junction will be forward biased, right? And base collector junction will be reverse biased. Now in diode, I told you about two capacitances. In forward biasing, we talk about diffusion capacitance, and in reverse bias we talk about junction capacitance. So that means for collector base junction, this junction capacitance is also named as transition capacitance. So that means the collector base junction is reverse bias, so it will have a transition capacitance, whereas base emitter junction is forward bias, so it will have diffusion capacitance. So this CD is the capacitance of base emitter junction, or you can say diffusion capacitance, whereas this CT is the junction or transition capacitance, and that is due to reverse biasing of collector base junction. So these capacitances are internal to BJT, whereas these three capacitances CC1, CC2 and CE, these are external capacitances that we have connected in the amplifier. So overall what you can say is there are 5 capacitances in the BJT, 3 are connected externally and 2 are developed internally. Now the question that comes to mind is, why does the gain reduce at low frequency? So always remember, at low frequency your CC1, CC2 and CE dominate. Okay, the transition and the diffusion capacitances do not dominate at low frequency. Now why is that? We know Xc is 1 by omega C. Now these capacitances are in the range of microfarad. So at low frequency Xc is moderate, because microfarad capacitance is considered as high capacitance. Okay, picofarad and nanofarad are low capacitances, but microfarad is high. So when you multiply omega into C, omega is low but C is high, so Xc will come out to be moderate, and that is why at low frequencies we have to consider these capacitances. Now why does the gain reduce at low frequency? The first reason is voltage drop across CC1 and CC2. These are connected in series. CC1 is connected in series with the supply, CC2 is connected in series with the load. Now due to voltage drop, V0 reduces. Now since V0 reduces, the gain which is equal to V0 by Vi, this also reduces. Okay, that is why the gain reduces at low frequency. The other reason is that CE does not completely bypass Re. Okay, if Re does not get short circuited, then it acts as negative feedback, and in negative feedback the gain reduces from its normal value. So if RE is not completely being bypassed, then the gain will definitely reduce due to negative feedback. Now, how to decide which capacitances are to be considered in which frequency range? So basically we have three frequency range. We have low frequency, or you can call it as LF. Then we have mid frequency, which we can call as MF. And at last we have high frequency, which we call as HF. Okay. Then we have two types of capacitances. One were the external capacitance, which were coupling and bypass. I told you these are high capacitance. Then we have parasitic capacitance. Which are the parasitic capacitance? Diffusion and transition. These are low. They are in the range of picofarad. Now in low frequency range, always remember Xc is 1 by omega c. Now omega is low, capacitance is high, so it will be moderate. We will consider it. Now here C, capacitance is low as well as frequency is low, so Xc will be very high. If omega is low and capacitance is also low, their product will be low, but 1 upon their product will be high. High means it will be open. Is it fine? So if capacitance and frequency both are low, then it will be open. In mid frequency range, we short circuit the capacitor, which we were doing earlier, and we open circuit parasitic capacitance. Okay. Earlier I told you when doing AC analysis, short circuit the capacitor. But I was never showing you the internal capacitances because internal capacitances were open circuited. What about high frequency? At high frequency this capacitance is high, omega is also high. So omega C will be very high. Omega is high, C is high, their product is high. So 1 upon product will be low. Low means short. But here omega is high and capacitance is low. So their product will be moderate. So we have to consider this capacitance. That means parasitic capacitances will be considered at high frequencies and external capacitances will be considered at low frequency. Okay. So when we will be studying low frequency and the high frequency response, we will only consider one kind of capacitances at a time. We will not consider all the capacitances simultaneously. Okay. So let us start. Now when we talk about the low frequency response, how was the low frequency response looking like? The low frequency response of BJT was something like this. If we only talk about low frequency, this was FL. Okay. It is similar to a high pass filter. Is it fine? I am not drawing the curve further. That is, I am not getting into high frequency range. I am talking about low frequency. So if you see only the low frequency curve, you will feel like it is a high pass filter. And that is why the circuit that I have given you, it is a passive. Passive means no active device. Passive first order high pass filter. Okay. Now in this case, if you want to derive the transfer function of this circuit, if we talk about transfer function, that is V naught S by VIS. It is equal to R. We are using potential division, divided by R plus 1 by SC. That is SCR over 1 plus SCR. That is your transfer function. Now you can go in the frequency domain That is, you can write the gain as a function of frequency by replacing S by j omega. If you are only interested in magnitude of the gain, then this will become omega CR by under root 1 plus omega CR whole square. Or you can write it like this, 1 by 1 plus 1 over omega CR square. Now what happens is, as omega tends to infinity, this mod of gain will become 1. That is, at high frequency the gain is 1. As omega tends to 0, 1 by omega will be infinity. If denominator is infinite, the gain would become 0. That means at high frequency gain is high, so it is acting as high pass filter. Now this function is also written in this manner, 1 plus omega h by omega whole square, where this, omega L, where omega L is actually equal to 1 by RC. Now see, at omega equal to omega L, this factor will be 1. So gain will be 1 by root 2. And that is what I told you about the cutoff frequency. It is equal to the frequency at which gain becomes maximum gain by root 2. Here maximum gain is 1. So when gain becomes 1 by root 2, we will get the cutoff frequency. So that means in this case the cutoff frequency is 1 by RC. If it is 1 by RC, you can write it like this in hertz if you come. This is omega. Omega means angular frequency in radian per second. If we want to write in hertz, what I'll write? FL is 1 by 2 pi RC, and this is the cut off frequency. Why I have made this derivation is because I am comparing the low frequency response of amplifier to a high pass filter. Now if I know the cutoff frequency of high pass filter, in a similar manner I can derive the cutoff frequency of the amplifier. Are you getting my point? If I can derive a similarity between these two, then definitely I can figure out the cutoff frequency of the amplifier. Now see, in the numerator we have maximum gain. The maximum gain in amplifier is your mid-band gain. So what I'll say, the voltage gain is nothing but the voltage gain in mid frequency divided by under root 1 plus omega L by omega whole square. Okay, and that is the voltage gain at low frequency. So what is this mid gain? This is the maximum gain, or you can call it as the mid band gain, because we know the gain is maximum in the mid band region. Is it fine? So now we will see how we can utilize this knowledge in order to determine the cutoff frequency of the amplifier. Now what I'll deal in this section is the low frequency response. And as I have told you, in low frequency response or in low frequency region, which capacitances will be considered? CC1, CC2 and CE. And I have also told you, what I have told you, that the cutoff frequency is given as 1 by RC. That means if I know the capacitance, I just have to figure out the resistance and I can find the cutoff frequency. Before going that further, first I will derive the AC model of this common emitter amplifier. For AC model, what you will do is, now you will not short circuit the capacitor, because we want to see the dependence of gain on frequency, so we don't short circuit the capacitor. Is my point clear? Now always remember, when you will short circuit the capacitor, we will only short circuit the capacitor when we are talking about the mid frequency region. Without mid frequency, no capacitor will be short circuited. Okay, so capacitors are only short circuited in the mid frequency region. Now we are talking about low frequency, so we have to consider the capacitance, we cannot ignore it. Now we know in AC model we ground this VCC. If we ground this VCC, as I have shown you multiple times earlier, R1 and R2 will be in parallel between base and ground. This will be R1 parallel R2. Similarly, this collector resistance will be connected between collector and ground, because VCC is now grounded. Then this CC2 is between collector and V0, and V0 is now connected to RL. Okay, like this. Now what we will do is, we will replace this BJT by its small signal model. So if I draw that circuit also, so which model will I use? I will make use of the RE model. Okay, so I am redrawing the circuit with BJT being replaced by its model. Okay, in low frequency region you can use any model, but as I told you in the previous videos, that at high frequency only we will make use of the hybrid pi model. This is your beta RE, this is IB. Then we will have a current source, beta IB. Then we will have, actually this diagram is not completely correct, because here I am not taking RE. Okay, so I'll draw it in the next slide. But what we'll do from now on, that I'll tell you here, we will only consider one capacitance at a time. See, there are three capacitances, which means it is a third order circuit. But the high pass filter that I showed you earlier only had one capacitance. It was a first order circuit. So in order to treat it as a first order circuit, what I'll do is, I'll only consider one capacitance at a time, and I'll figure out the cutoff frequency associated with that capacitance. How I'll find the cutoff frequency associated with that capacitance? Simply, it will be 1 by 2 pi RC, or in radian per second you can call it as 1 by RC. Okay, but from now on I'll only consider one capacitance at a time. Is my point clear to you? So now, for considering the effect of CC1, I'll replace BJT by its small signal model. But remember, when you are considering one capacitance at a time, the other capacitances will be short. Okay, other capacitances you have to consider as short circuit. This much is fine. Now see, what will happen is, first of all we are considering the effect of CC1. That means this CE will be short, CC2 will also be short. If CE is short, this RE becomes short, and ammeter gets connected to ground. So if I draw the circuit again, this is Vs, then RS CC1 this resistance was R1 parallel R2, this was ground. Then we had a resistance beta RE. Ammeter terminal will now be grounded. This current source was beta IB, where IB was the current in this beta RE. I will not consider R0. RC was the resistance between collector and ground. Since CC2 is shorted, it will be connected in parallel with RL. Now I have to find the transfer function V0 by Vs. For that I first need IB. So how you will find IB? First of all, what I will say, this RC and RL are in parallel. If they are in parallel, what I will do is I will remove one resistance and I will write here RL parallel RC. So this beta IB is flowing like this, but V0 is like this, which means plus minus polarity will be opposite to the V0 polarity. So V0 will be minus beta IB into RL parallel RC or RC parallel RL. Now we need IB in order to find the voltage gain. How to find IB? These two resistances are in parallel first of all, and this capacitance can be replaced by 1 by SC. So I'll first say R equivalent is R1 parallel R2 parallel beta RE. Then what I'll do is I'll apply voltage division. I'll try to find this voltage V. V is Vs into R equivalent by R equivalent plus Rs plus 1 by SCC1. Okay. Now once you have V, you can calculate IB. IB is nothing but V upon beta RE. That means Vs R equivalent by beta RE by R equivalent plus Rs plus 1 by SCC1. If you substitute this value in V0, what you will get? Minus beta IB, beta will get cancelled. Vs R equivalent by RE into RC parallel RL by R equivalent plus Rs plus 1 by SCC1. Once we have this value, we can calculate the voltage gain, that is V0 by Vs. So it is minus, how much will it come? R equivalent by RE into RC parallel RL into SCC1 if we take LCM, then 1 plus SCC1 R equivalent plus Rs. Now earlier we saw in high pass filter the transfer function was SRC over 1 plus SRC. So if you compare this, then you can say in the denominator the term with S represents the cutoff frequency. So you can say coefficient of S in denominator is cutoff frequency, which is omega L. Okay, because there, 1 by omega L, because there I told you that the cutoff frequency is 1 by RC. So here also what you can say from this expression, that the cutoff frequency will be 1 by R equivalent plus RS into CC1. What was R equivalent actually? R1 parallel R2 parallel beta RE plus RS into CC1. Okay. But there could have been a direct method to derive this expression. How? If you see, if I redraw this loop, if I redraw this loop here, I am short circuiting the supply, I am open circuiting this capacitor. This resistance was R1 parallel R2. This was beta RE. This was RS. Okay. Now if I ask you to find the Thevenin resistance across AB, if I want to find the Thevenin resistance across capacitor or AB, then what will be the resistance? It will be RS plus R1 parallel R2 parallel beta RE. That will be the resistance, and that is the same resistance coming in the denominator. So you can directly say it is 1 by RTH into CC1. That is, you have to calculate the Thevenin resistance across CC1, and then you can directly figure out the cutoff frequency. You don't always need to derive the transfer function. Is my point clear to you? You can either derive the transfer function and compare it with a high pass filter, but if you want to do it quickly, just find Thevenin resistance across the capacitor. Next, if I want to find the cutoff frequency associated with CE, in this case CC1 and CC2 will be shorted. So if I draw the circuit again using small signal model, this is Vs, Rs. Now I will short circuit CC1 and I will directly show the next resistance, R1 parallel R2. Okay, here there was CC1 which is now shorted. Then we have a resistance beta RE. The current in this resistance is IB. This terminal was ground, but this was connected to ammeter. This is base, this is ammeter. Ammeter had a resistance RE, in parallel to which we had a capacitance CE. Okay, since we are talking about CE, I cannot short circuit CE. Then we had a current source here, beta IB. I am not considering R0. This is your collector terminal. Between collector and ground, we have a resistance RC. Then we have CC2, but CC2 will be now short circuited. So I will directly show the load resistance RL. So again what I wish to find is, I wish to find the cutoff frequency associated with C. So first thing that I'll do is, these two resistances are in parallel, so they will be combined into one resistance, and that one resistance will be RL parallel RC. Now we can see that this beta IB current will be flowing like this. This is V0. But the polarity of voltage in resistance will be like this. Okay. So if it is like this, what I can say is that V0 is minus beta IB into RL parallel RC. But again I need the voltage gain or the transfer function V0 by Vs. For that I will change this capacitance into 1 by SC. That is, I am going into Laplace transform. So how to find this V0 by Vs? Okay, what should be the step? So what I will do is, Suppose, in order to simplify this, for simplification, just for simplification, what I am going to do is ignore RS. Okay. Suppose this RS is ignored. That is, I am short circuiting this RS. So Vs is the voltage here. That means the overall voltage here will also be Vs. First, what I'll do is I'll combine these two resistance and capacitance into an impedance. So Z will be Re into 1 by SCE by Re plus 1 by SCE. That is Re by 1 plus SCE into Re. Now here the current is IB, here it is beta IB, so the current here would be 1 plus beta IB. Okay. So now we know the total voltage is Vs. Vs, if I apply KVL, like this, so what I'll say, IB, actually this resistance is not beta Re but 1 plus beta Re, which we approximate as beta Re, plus 1 plus beta IB into Z. That means 1 plus beta IB Re plus Z, or you can say IB is Vs over 1 plus beta Re plus Z. Now we know V0 is minus beta IB RC parallel RL. Beta and 1 plus beta are approximately equal, so it will get cancelled. So it is minus RC parallel RL over Re plus Z. That means the gain of the amplifier is minus RC parallel RL over Re plus Z. Z was Re over 1 plus SCE Re. Now if you take the LCM, what it will become? Minus RC parallel RL, okay, into what will happen? 1 plus SCE Re by Re 1 plus SCE Re plus Re. So this gain will become minus RC parallel RL 1 plus SCE Re upon Re plus SCE capital Re into small re. Now in the denominator I need a term something like 1 plus S into something. Okay, that is 1 plus S into something, that sort of a term is required. If that sort of a term is required, I'll take this common. Minus RC parallel RL, okay, 1 plus SCE Re are divided by Re plus small re whole divided by 1 plus SCE Re over Re plus Re. Okay. Now we know that by looking at the coefficient of S in the denominator, we can tell the cutoff frequency. So what I can tell is the cutoff frequency here is 1 by coefficient of S. The coefficient of S is CE into Re small re by Re plus small re. That is 1 by, this is capital Re in parallel with small re multiplied with Ce. That is the cutoff frequency associated with Ce. This you could have find directly again by finding the Thevenin resistance across this capacitor. How? I have told you, whenever you want to refer the resistance from base to emitter, what to do? Divide by beta. If you divide by beta, it will become small re. It will be in parallel with capital Re. So the equivalent resistance across capacitor will be capital Re parallel small re. What I have said? Refer beta Re to emitter. When you refer it to emitter, it becomes from beta Re to Re. This Re is connected in parallel with capital Re. So this will be the Thevenin resistance across C. So remember, whenever you want to find the cutoff frequency, what you have to do? You have to find the Thevenin resistance across a capacitor, and once you do that, you can find out the cutoff frequency simply as 1 by RTH into C. So let us move on to our third capacitance, which is CC2. So if you see on the collector side, now I will find directly, if you see on the collector side, what we have is a current source beta IB. Okay, this terminal is emitter. But when you are studying CC2, CC1 and CE, they will be shorted. If CE is shorted, emitter is connected to ground. This is collector. We have a resistance between collector and ground, which is RC. Then we have a capacitance CC2. And this is V0. Across V0 we have a resistance RL. Now this both are grounded, so they both can be connected. Now if I ask you what is resistance across CC2, RTH across CC2. If I want to find that out, what I'll say is RTH across CC2 is RL plus RC, which means the third cutoff frequency that is associated with CC2 is 1 by RL plus RC into CC2. So that means here I have derived three cutoff frequencies, one using CC1. CC1 cutoff frequency that we derived was 1 by RS plus R1 parallel R2 parallel beta RE into CC1. The second cutoff frequency due to emitter capacitor, that was RE parallel small re into CE, and this one is the third one. Now, but in your amplifier frequency response, I showed you only one cutoff frequency FL. Here we have three cutoff frequencies, omega L1, omega L2 and omega L3. So how we find FL? FL is the maximum of FL1, FL2 and FL3. FL means nothing but omega L over 2 pi. Okay. Now why I have taken maximum? C. If there is one function like this which is passing everything above 10, then there is another function which is passing everything above 15. If I ask you, if we use these two systems, which frequencies will be passed? You will take the intersection. So one system is saying frequency must be greater than 10, other is saying frequency must be greater than 15. If you take the intersection, what you will get? Frequency greater than 15. That means when we have FL multiple values, we consider only the maximum out of all those values. So your lower cutoff frequency will be the maximum of the 3 frequencies that you have derived. Okay. Moving on to the last term in the low frequency response is called as unity gain frequency. Just now we have seen that the low frequency gain is given by mid frequency gain divided by under root 1 plus omega L by omega whole square. Or if you replace omega as 2 pi f, 2 pi will get cancelled. It can be 1 plus FL by f square. Now unity gain frequency means frequency f equal to ft at which this gain becomes 1. The frequency at which the gain is 1 is called as unity gain frequency. This is AV mid over under root 1 plus FL by FT whole square. Now if I say FL by FT is much greater than 1, then you can say 1 equal to AV mid divided by FL over FT, which means this FT will become FL over AV mid. Okay, this frequency is called as your unity gain frequency. So no need to remember anything. Unity gain frequency is nothing but the frequency at which gain becomes 1. So if I summarize what we have learnt in this video, that when we talk about low frequency response, in that which capacitances are considered? CC1, CC2 and CE. Then in high frequency response, which capacitances are considered? Diffusion capacitance and transition capacitance. And how to find cutoff frequency? 1 by 2 pi into RTH into C. RTH is Thevenin resistance across C. So I told you we derived 3 cutoff frequencies, FL1, FL2 and FL3. Then FL is taken as maximum of the 3 cutoff frequencies. So what you have to do? Always remember, design the small signal model including the capacitances and find Thevenin resistance across each capacitance. But consider only one capacitance at a time. After doing this, you can find the 3 cutoff frequencies and the maximum of that will be your overall cutoff frequency. Okay, this you have to remember when you are dealing with the low frequency response, or you can say coupling and the bypass capacitor. Okay, so in the next video I will tell you about the high frequency response. Thank you.
I hope all of you have enjoyed the lecture that we were providing and all of you learned something very good. Now is the time to learn about the Unacademy subscription. So as I told the benefits of the Plus subscription at the very beginning, let's go through them very quickly. Live classes you get by the top educators, crash course, rank improvement batch, doubt clearing, weekly quiz, test series, previous year question, practice question, everything in one subscription called as Unacademy Plus. And iconic is one level higher. It provides you a personal coach who will mentor you on a daily basis, who will guide you on a daily basis, along with providing you study planner, test analysis, study material, and soon enough interview guidance. So if you are looking to join Unacademy, let's see what are the pricing. So my dear friends, before we see the pricing, just see the link. This link will help you crack GATE and ESE with the top rank, because we have created the first ever video book for GATE and ESE for my YouTube family, and you will get the notes as well as the lectures here. Just make sure that you write this link in the uppercase and you will get to the first ever video book for GATE and ESE, and it is nothing but revolutionary. Now let's see the pricing of plus subscription. So for 12 months, the pricing is 3250, but if you apply the code Ankit ESE, it becomes 27225. For 18 months, it will be 34650, and for 24 months, 39600. Believe me, my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here, it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for Iconic for 12 months, it is 5250. With code Ankit ESE, it becomes 45225, and 2-year subscription becomes 66600. So the choice is yours, but take a longer duration subscription for more cost effective solution, and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that, my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live, you will get the notification. That we have other YouTube channels like Mechanical, Civil and Telugu, JE channel, Computer Science, GATE Question and Electrical Junction, Pathshala and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JE preparation can be done through these 2 channels, Unacademy SSC JE and GS Terminal. And you can refer the other channels to the other friends in respective branches, so that they can also be benefited. At last, I would like to say, please share, like and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon, so that you get notified whenever a new video comes. And share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well, and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.